this lesson is about special right triangles. Certain right triangles have properties that allow you to use shortcuts to determine the side lengths without using Pythagorean theorem. For example, the acute 45 right triangle has another name. It's called an isosceles right. We talked about this, I think, in class. I think all classes talked about it. But the isosceles right triangle means these two sides are the same length. It has a special relationship between the sides. It doesn't matter how long the sides are. They always hold this relationship. So they have a ratio, a relationship between the sides, like I said. So in order to go from this side to that side, if I know this is 2, then this is 2 root 2. If I know this is 5, this is 2 root 5. If I know this is 4, this is 4, and 4 root 2. So you just multiply to get from there. But if I'm given this one, let's say this one is 4, to go from here to there, I would divide by root 2. So again, to go from the hypotenuse to the sides on a 45 degree, on a 40, 40, 90 right triangle, I would divide by the square root of 2. Because x root 2 divided by root 2 is going to give me x back. The other special right triangle we're going to talk about is a 30, 60, 90. It has a relationship of 1 to square root of 3. Basically, if this is 2 times 2, which is 4, and this is 2 times root 3. So to go from here to the others is easy. Going backwards is a little harder. If I'm given the hypotenuse and I want this side, I have to divide by 2, because 2x divided by 2 is going to give me x. If I have this side and I want to go here, I'm going to divide by root 3. From here to here is division by root 3. If I'm going to go from here to there, though, I have to divide by root 3 and then multiply by 2. So you have to know your relationships and be able to identify which ones are which. And remember, the 60-degree angle is opposite the x root 3. So if you're looking at length of sides, this is my shortest side, the middle side, and the longest side. Okay? So now we're going to find some missing sides from these examples right here. So if this is 2 root 2, notice this is my 45-degree angle, this is my hypotenuse. To get from here to there, I multiply by the square root of 2, right? To get from here to there, I multiply by root 2. So to go from here to there, I'm going to multiply by square root of 2. So this is going to be 2 root 2 times the square root of 2. We're going to leave stuff in radical form when we work on them this time. So when I multiply radicals, I multiply what's inside. So I'm going to have 2 root 2 times 2, which is 4, right? But the square root of that is 2. So this is going to give me 2 times 2. So u is equal to 4. And then, because this is an isosceles right triangle, v is 2 root 2. Okay? Now, this is a 30, 60, 90. So it is a given if this is a right triangle and this is 30 degrees, this is 60. If this is a right triangle and they tell me this is 60 degrees, then I know the other one is 30. So here we go. I'm looking for the shortest side. So 30 is opposite. Remember, the smallest angle is opposite the shortest side. So this is my shortest side. To go from my longer side, or my longer leg, to my shorter leg, I have to divide by the square root of 3. So going this way, I'm going to divide by root 3. So I'm going to have 3 root 3 over root 3, which tells me that y is equal to 3. Right? And then to go from here to there, well, I know this y value here is 3, and that the hypotenuse is twice that. So x is going to be 2 times 3, which is 6. So x equals 6. All right, let's do a 45 again. So my 45, that means I know that this is an isosceles. That means this is 3 and this is 3, so y equals 3. And then to go from the short side to the hypotenuse, I multiply by the square root of 2. So then x is going to be 3 root 2. And I cannot simplify that, so I'm going to leave it like it is. Okay, I'd like you to try those. try those. Pause the video. Did you get these answers? If you didn't, we probably need some clarification, so ask me during the notes question time. Okay, so going on to the next part. Sometimes we have to do more than one step to figure out an answer. So in this particular case, they give me the side of a 45, but I need the side of the 60, of a 30, 60, 90. And so I know I'm looking for the longer side, but this is the x value. So this is my shortest side. I know it's the hypotenuse of my right triangle. So to get from here to there, I'm going to go from the leg to the hypotenuse. I'm going to multiply by square root of 2. So I'm going to take my 6, I'm going to multiply it by root 2. Okay, now this is for my 45. Now to go from my 60, to go from my short leg to my long leg, I am going to multiply by the square root of 3. So now I'm going to take this and I'm going to multiply it by the square root of 3. When I multiply radicals, multiply what's inside, so 6 times the square root of 2 times 3. 2 times 3, neither of those are perfect squares, so then I'm just going to multiply them. So this is 6 root 6. Okay? Over here, again, I'm going from a 60, a 30, 60, 90 triangle, to the hypotenuse of a 45. This is my shortest side because 30 is opposite it, so this is my shortest side. So going from the short leg to the long leg, again, I'm going to multiply by the square root of 3. So I'm going to have 9 root 2, and then multiply it by root 3. That's going to give me 9 root 6. Then, to go from, this is my 60, right? Then, to go from my 40, I have a side, and I'm going to the hypotenuse. So I'm going from the leg to the hypotenuse. And that means I'm going to multiply by the square root of 2. So I'm multiplying this by the square root of 2. This is going to give me 9 root 12, right? 6 times 2 is 12. Then, because 12 is actually 3 times 4, and 4 is a perfect square, I know that I'm going to take that. So I'm going to have 9 square root of 4 times 3. And the square root of 4 is 2. So I'm going to have 9 times 2 times the square root of 3, which is going to give me 18 root 3. Okay, now I would like you to try these. Give those problems a try. Whoops. Give those problems right there a try. And pause the video to do so. Did you get these answers? If you did not, then you need to ask me about them when we do notes. All right. Now, the practical application of these 30, 60, 90 triangles work with estimating heights of things or lengths of things. And so, using the 30, this is a 30, 60, 90 triangle, right? There's my right angle, that makes this 30 degrees. So this is my short side. To go from my short side to my hypotenuse of a 30, 60, 90, I multiply by 2, right? So I'm going to multiply this by 2. That's going to tell me that this is 100 degrees. 100 meters. So on this one, I 30, 60, 90, here we go. That makes this 30 degrees. That makes this my short side. That makes this my longer side. So to go from here to there, I have to first divide by the square root of 2. That will give me this length, and then I'm going to multiply by 2. Okay? So I'm going to take the 6, divide by root 2, and then I'm going to multiply by 2, which is going to give me 12 over root 2. Okay, now this is not simplified form. You can't have a radical in the denominator, just like you can't have a decimal. So to get rid of the radical that's in the denominator, I'm going to multiply by the thing that will make it no longer be inside the radical. In this case, since it's root 2, I'm going to multiply by root 2. So that's going to give me 12 root 2 over the square root of 4, which is 2. So then I'm going to have 12 root 2 over 2. And then I'm going to simplify that. This is going to give me 6 root 2. So my answer is 6 root 2 meters. Okay, if you're having problems keeping your radicals or dealing with your radicals, let me know, and I'll go over them with you.